Hey crew. Okay, so today we're going to talk about the difference of squares and how to factor. So as long as you know what your squares are, this should be a pretty easy maybe day of factoring. For instance, if I look at 1 squared is 1. So 1 is a square. 2 squared is 4, so 4 is a square. 3 squared is 9, so 9 is a square. Then we get 16. We get 25, we get 36, we get 49, etc. Okay? So the first one we're going to do is we're going to do x squared minus 9. Okay? It's called the difference of squares because it's a minus sign in the middle. If there's a plus sign in the middle, you're not going to be able to factor this. Okay? Now it talks about the difference. We talked about that. That's subtraction. And then squares. Now if I look at this, I know that x times x is x squared. So x squared is a perfect square. And if I look at 9, we get 3 times 3. So that is a perfect square. Now, the way this factors is we need two sets of parentheses. We're going to have x and x, 3 and 3. Now, to get a negative sign, if I take a positive times a positive, does that give me does that give me a negative? No. If I take a negative times a negative, does that give me a negative? No. The only way this is going to happen is if I take a positive times a negative. So I'm just going to go positive, negative. Okay, now I can double check this. X times x is x squared, or if you'd rather make a box, this is what it would look like. Okay, then we take x times negative 3, that's negative 3x. We're done with x. 3 times x is 3x. 3 times negative 3 is negative 9. Now, if I look at simplifying this, negative 3, positive 3, that's 0, that's gone. So we're back to x squared minus 9. So this was indeed the way to factor it. Okay, my next one. We've got x squared minus 25. I have a minus in the middle. That's looking good. So we take x times x to get x squared. And we take 5 times 5 to get 25. And then we need a plus minus. Okay, how about this one? It's a little harder. 4x squared minus 1. Okay, well, to get to 1, we need 1 and 1. How do I get to 4x squared, though? Well, square root of 4 would be 2, right? 2 times 2, so 2x times 2x is 4x squared. One's a plus, one's a minus. What if that would have said something like negative 9x squared plus 16? Now you notice it's not the difference of squares, but if you go back to the other lesson, we don't like the negative out front here. So we're going to factor out a negative or a negative 1. We're going to divide everything by negative. That becomes positive. Now our 16 becomes negative. Now I have the difference of squares. Well, 3 times 3 gives us 9. So 3x times 3x is 9x squared. 4 times 4 is 16. Positive, negative, and don't forget the negative that we pulled out before. Okay, a little trick here. 25x to the 4th minus 36y to the 6th. I'm not starting with a negative here. I have a minus in the middle. 25 is a perfect square, so is 36. Now I'm also going to tell you this. Any even root is a perfect square. Or I can write it as something squared. Okay. So I have 5 and 5, 6 and 6. Now, if I take x squared times x squared, that gives me x to the 4th. And if I take, I should have left more room, y to the 3rd times y to the 3rd, I get y to the 6th. So basically, when we look at our exponents, we're halving them. Half of 4 was 2, half of 6 was our 3. And then we need our plus and our minus. Okay, the last one I have for you. 125x to the 5th minus 20x cubed. So if you look at these, one thing that sticks out for me is that we have odd roots now instead of even roots. And we can only do it if it has, or excuse me, odd exponents instead of even exponents. All right, but I notice they both have x's, so we can factor something out. I also know that 5 goes into 125 and 20. So I'm going to factor out a 5, and I'm going to pull out 3 x's also. If I take 125 divided by 5, it's 5. I need 2 more x's. Minus 20 divided by 5 is 4. And I don't need any more x's. I forgot the 2 here. Right, 5 times 25 is 125. Okay, so now if I'm looking, I have a minus in the middle. I know 25 is a perfect square. 5 times 5. Don't forget my x. And I know 4 is a perfect square. 2 times 2 plus minus. And then we have 5x cubed out front. Now, actually, I have one more hard one to give you. Let's take x to the 4th minus 81. X to the 4th minus 81. Okay, well, x to the 4th is a perfect square. It's x squared times x squared. 9 times 9 got us to 81. We need a plus and a minus. Now, I have to be really, really careful when I still have perfect squares here because I need to see if I can break that down even further. Now, I know that I am done with this one because I have a plus sign in the middle. I need to check out this one though with the minus sign in the middle. I know x squared is a perfect square. What about 9? Yeah, it's 3 times 3. So I'm going to break down this set as x times x, and then 3 times 3, 1 plus, 1 minus, and I have to still write x squared plus 9. Okay, now I know I'm done because I'm just left with a single x, and obviously it's not a perfect square. So, kind of tough, kind of fun. Let me know if you have questions, and good luck with your assignment.